let's look at what we have with this one. So for this question, I have a jet plane that's originally going at 100 meters per second, and it is going to land, so its acceleration is going to be in the opposite direction of its motion, so it's negative. And when it's going to come to a rest. So we want to know how long it takes for it to come to a stop, and we want to know, can it land on an 800-meter runway? So let's take a look at the information we have and make a list of that first. Let's see, my initial velocity is here. There's my V naught. It's coming to rest, so that's my V final. And here is my acceleration. Cool. So I have V naught equals 100 meters per second. V final equals 0 meters per second. And acceleration is going to be negative 5.00 meters per second squared. So essentially what I'm going to do is define, here's my plane. Well, that's kind of a plane. Let's see, wings. There we go. It is going this way, is its velocity, and I'm going to define up and to the right as positive. So that is why my acceleration is negative, because I'm defining the direction of the velocity to be positive. So the time to stop, I look at this, and this one is definitely going to be the easiest one to start with. So V final equals V naught plus AT, because I've been given acceleration. Oops, I forgot to make a note. What do I want? I want time, and I want delta x. Okay, so what can I cross out? My V final is 0. So moving it over, my V naught over to the other side, I end up with negative V naught equals negative AT, because the negative sign. So moving acceleration to the other side, I get negative V naught divided by negative A. Again, A is negative only because it's in the opposite direction. So my negative signs are going to cancel out. And finally, I'll just have that my velocity divided by my acceleration will give me my time. Cool. So I can do that. Let's go ahead and solve that one. That I have 100 meters per second divided by 5 meters per second squared. Again, quick check on my units. Meters is going to cancel with meters, and one of my seconds will cancel here, and I'll end up with a second on the bottom, which pops it up top. And it goes. So let's actually, let me do that. I have meters over seconds divided by meters over seconds squared. So remember, with fractions, the top is going to stay underneath the fraction line. The seconds is going to pop up top over here. So I can rewrite this as meters times seconds squared divided by meters times seconds. It cancels. And that cancels. So I do indeed have units of seconds, so I'm good. So 100 divided by 50 is 20 seconds is how long it takes. Let's put a box around that. And then the next one is, can it land on an 800-meter runway? Well, one of the easier ways to fix or to calculate that is just to figure out how much of a runway does it need. So it really is preference here. So I have a delta x here, x and an x naught. I have a delta x here. I know my acceleration. I know my V final. This one involves time. I can use the time that I just solved for to get there. Or I look at this one and I'm like, well, my V initial squared, I know acceleration. I could have jumped right to that one if I wanted. So I can go V final squared equals V naught squared. Let's make a note, that's for A. Equals V naught squared plus 2A delta x. V final is 0. So I get negative V naught squared, just moving this to the other side, equals 2A delta x. I'm going to remind myself that the acceleration is negative. So my delta x is going to be just dividing by the 2a, negative 2a on both sides. Gives me an equation of negatives cancel out. V naught squared divided by 2a is my delta x. So putting that in, I have 100 meters per second squared divided by 2 times my acceleration is 5, and that gives me my delta x. So drum roll, do you think it will fit or not? Divided by, I almost put in 2 times 5. So it needs 1,000 meters. Nope, not going to make it. So no, can't land on 100 or 800 meter runway. 800 meters. Cool. So what you will see is as we progress, I'm going to include kind of fewer and fewer details. These aren't going to take as long. I'm just really trying to emphasize kind of the logic, thinking it through, and give you all the full details.